So we'll just do a few more of these application problems. So we've got a security camera in a neighborhood bank is mounted on a wall 8 feet above the floor. So here's the wall that's 8 feet above the floor, and there's the camera. Okay. What angle of depression should be used if the camera is to be directed to a spot 5 feet above the floor and 12 feet from the wall? So we're going to go 12 feet from the wall and 5 feet above the floor. So this is 5 and this is 12. And I want to know what my angle of depression should be. So just like an angle of elevation means that you're going to look up, an angle of depression means that you're going to look down. Okay, so I need that angle. Instead of going straight across at 0 degrees, how far down do I need to tilt this thing to go to 5? So I know if this is 5, this must be 3. And I know that this is 12. So now I know if I am looking at this triangle right here, that I can find the angle measure that I'm looking for by using arctangent. So the tangent of theta will be 3 over 12, or 1/4. And then take the arctangent of both sides. So I'll have the arctangent, so theta equals the arctangent of 3/12, or 1/4. It's going to give you the same answer. So I have the arctangent of 3/12, and I get 14 degrees. So this angle measure right here must have dropped down 14 degrees. So angle of depression, you don't have to put negative 14, because angle of depression tells you it's dropping down. All right, so let's try some more. A DC-9 aircraft leaves an airport from a runway whose bearing is north 43 degrees east. Okay, so I've got this, and I'm going to go north, and then I'm going to swing out 43 degrees east. So I'm going to go this way, and then this is 43 degrees. Okay, I do that for a half of a mile, because apparently I know how to fly a plane. All right, so the pilot flies this way for a half of a mile. Once he gets to the half-mile point, this guy's doing a lot of stuff really fast. All right, so for a half of a mile, the pilot requests permission to turn 90 degrees and heads towards the southeast. So we're going to go this way. So there's my 90-degree angle. And I want it to go to the southeast. The permission is granted after the airplane goes 1 mile in this direction. So this is 1. What is the bearing that the control tower should use to locate the aircraft? So I want to know where is my aircraft. Okay, so first of all, I need to know a few things. I know that this is 1/2. Okay, this is 1/2, and this is 1. And so what do I need to know? I need to know this little part right here as far as how far down that thing dropped. Okay, because if I know how far it dropped from the axis, then I can figure out its complement, and it's going to be south, and I'm going to swing the thing to the east in order to find my aircraft. So I do know it's going to be south something degrees to the east. I've just got to find out how to get to this little part right here. So what do I know? I do know that I can find this angle measure right here, which will then inform me of this angle measure right here. So let's get started on that first. So ignore this pencil part, and we're going to go in here. What did I just say about ignoring the pencil? All right, so we're going to go in here. We're going to find this angle measure. And so that angle measure is going to be the tangent of theta is going to be 0.5 over 1, okay, which is 1/2, okay? And then I'm going to do the arctangent of both sides. So I get the arctangent of 0.5 over 1, which is 1/2, okay? So the arctangent of 1/2 is going to be 26.57 degrees. So this is 26.57 degrees. So 26.57. Well, now I need to know, I know this part is 43. Okay, I can now figure out this entire angle in this bigger triangle. So this bigger triangle, because if I subtract everything from 180, this is 90 degrees, this is 26.57. So 180 minus 90 minus 26.57 gives me that this angle is 63.43. So this part, look at all my colors, is 63.43. So 63.43. Well, I know that this much of it is 43 degrees. Okay, so let's shade this in just a little bit. This much of it is 43 degrees. I need to know how much further it dropped down from the axis. So I need to add these together and subtract 90, and that's going to tell me how much further I dropped down. Okay, so 90 minus 43 minus 63.43 tells me I dropped down into the axis 16.43 degrees. Okay, so this part right here, let's shade him in. That part is 16.43 degrees. So what did I do? I took all of the answer of this. I added up the 63.43 plus the 43, and I got 106.43. And then I subtracted off the 90 degree angle from here to here, and that told me the part that dropped down. So if the part that dropped down is 16.43, so that part is 16.43 degrees, then how far did I swing over? Okay, I know that this part of the 90 degree angle is 16.43. I need to know how far I swung over. So 90 minus 16.43 gives me 73.57. So I went south 73.57 degrees east. So started south, and I swung over 73.57 degrees towards the east. Okay, so let's do, you can do that one. We need to remember how to do scientific notation. So let's do scientific notation. One method of measuring the distance from the Earth to a star is the parallax method. So let's zoom in on this. And we have the Earth at time 1 is here on its orbit around the sun. This is the Earth at time 2, and we try and get opposite sides, so about 6 months apart. Okay, and then I can measure the distance to my star, and then I can find the parallax, which is going to be that angle right in there. So what do I know? First of all, a star is 6.6, you can't see. A star is 6.67 light years from Earth. If 1 light year is about 5.9 trillion miles, how many miles is the star from the Earth? Okay, so this is just simple arithmetic. What I have is 6.67 light years from Earth. Okay, and I know that 1 light year is 5.9 trillion miles. So how many miles am I away? I just need to take 6.67 times 5.9 trillion, which is going to be roughly 40 something-ish, because this is roughly 6 and this is roughly 6. So round up. So 6.67 times 5.9 gives me 39,353. So it's 39 trillion. Okay. So 39 trillion 353 billion. So 39.353. 39 trillion 353 billion. No millions and no thousands and no ones, hundreds, whatever's. Okay, so I've got 39 trillion, billions, millions, thousands, and single places. I forgot what you call those. All right, so that is how far away the star is from the Earth. Now, I would like to know what that is in scientific notation. So remember, with scientific notation, I need to move this thing however many times until I get to a lead digit between 1 and 9 inclusive. So right now I'm going to keep moving my decimal point, which is here, and I'm going to move it to the left until I get to here. So my lead digit will simply be between 1 and 9 inclusive. So 3 is between 1 and 9. So my answer is 3.9353 times 10 to the, and this is a huge heifer number. How many times did you move that decimal place? So I've got 3, 6, 9, 12, 13. So I moved it 13 times. Okay, so the mean distance from the sun is about 93 million miles. What's the parallax of this star? So we're going to draw a picture. So we have the mean distance of the sun. That was lovely. I want this angle right here. Okay, so this is the star. So if we look at our picture, I'm just doing the lower part of that triangle. And the mean distance from the sun, or from the Earth to the sun, is 93 million. So this is the Earth and this is the sun, and that must be 93 million miles. I know that this side is 39,353, and I'm going to go ahead and write it out. So this is 39,353, 000,000,000, which you can do this in scientific notation if you want to. I'm assuming it's been a bit. So what do I know? I want to know what that angle is, or what the parallax is. So what do I know? I know opposite over adjacent. So I do not. That is opposite over hypotenuse. So the sine of that angle is going to be opposite, which is 93 million over 39,353. And then 1, 2, 3, 1, 2, 3, 1, 2, 3. And then what we're effectively going to do is divide off all the extra zeros. So I'm dividing by 1,000,000 on the top and the bottom. So that leaves me with that answer right there. And now I can take the arc sine. So the arc sine of this angle, the arc sine of this ratio will tell me the angle. So 93 over 39,353,000 will tell me the angle. So from here, what I did was I took the arc sine of both sides, and then I just cleaned it up. So now I know what theta is. So the arc sine of 93 over 39353,123 is, you can't see what I just did, is going to be 1.35402, and then I got an e to the negative 4. That's scientific notation. It's telling you you've got times 10 to the negative 4. So rewriting this, I've got 1.35 402 times 10 to the negative 4. So that's what that negative 4 means. And it says I'm supposed to actually give my answer to 6 decimal places, which means it doesn't want scientific notation. So I need to move this. This is a tiny number, so since this is negative, I'm going to move left 4 spots. So I need 3 lead decimals. So this is no longer here. So I just moved it. So since I did this part, I now have how many decimal places? 1, 2, 3, 4, 5, 6. So that right there is my answer for the degree measure of my parallax. Okay, so those last few you can do. So I will see you for 9.2.